All right, guys, welcome back. We are going to work on how to code messages today. So, the field of coding is called cryptography. It is mostly widely used for military purposes. When you want to send messages, you don't want them intercepted, they are going to be sent in a coded way. This was the most famous thing in World War II. In World War II, the Allied troops were able to break the Nazi code. It was said to be the turn in the war. It was said to be the reason why the Allied troops beat the Nazis. In today's world, coding messages is the internet. So you can't put your credit card information into a web page and think it's going to get to the right place without being intercepted unless it's coded. It's called a secure socket layer. It is the entire idea of encrypting messages. We are going to look at two ways to code messages. So, a good coding or encoding process or encrypting is one that makes coding and decoding very easy if you know how the code was made. You don't want to make something too difficult so that the person that's supposed to receive the message can never actually get to the bottom of it because it's too hard for them. So, we are going to look at two effective coding strategies, just two. Our first one is called a shift cipher. So, if you want to, just a reminder where you are in the notes, this is page 7 of the notes. We're doing this page 7. We're talking here about Julius Caesar. So, Julius Caesar used a simple shift cipher to code his messages to try to prevent his enemies from finding out his plans. Back in Julius Caesar's day, you would make a message, you would hand it to someone, they would ride on horse and deliver it. So anyone that person got intercepted with could steal the message, but he used a shift cipher to code it and make the message not understandable. Here's how all of our coding works. Our coding works with the alphabet and numbers related to the letters. We're going to try it with two methods. So, this is what a shift cipher is. A shift cipher is basically take every letter of the alphabet and just shift it either further to the right or further to the left and get the new letters. That's it. All of them the exact same amount. So what you see here is this was used by a shift cipher of +3. That means this was made by +3. Let me slow you down. So if something was made by +3, the only way to decode it is to subtract 3. So if I'm looking here at the letters here, P, and I see where's P, and I see it's right here, the only way to get back to what the original letter was to -3. So if I go from P, -1, -2, N goes back to -3, my first letter would be M. D, -3, -1, -2, -3 is A. Again, if we had to get like B or A and you have to -3, you go to the back of the alphabet. Or you go to the front, whichever way you need to go. It just recycles. W, -3, -1, -2, -3, T. K, -3, -1, -2, -3, math, space. Then we have L, V, L, -1, 2, 3 is I. V, -3, 1, 2, 3 is. I think we're getting the hang of this. I, -3, -1, 2, 3, F. I think you can guess this one. X, -3 is U. Q, -3 is N. Math is fun. So, moral of a shift cipher. The +3 is how you coded it. So to decode -3. So +3 is how it's made, -3 is how it's decoded. It's called a shift cipher again, guys. Shift cipher. So this is the famous message that Julius Caesar did using a +3. So if we wanted to decode it, we would use a -3. So for the first letter, for instance, -3 from E becomes B. And this is going to be his famous "Beware the Ides of March." That means the mid of March. It was a reference to weather being really bad in the middle of March, typically. So that's all a shift cipher is. If you want to stop right here and go to page 21 in the notes, this is where you're going to practice this. You'll see the first 4 questions on page 21 of the notes is shift ciphers. So what you're going to do is choose a sort message. You're going to choose how you want to shift it. You're going to code it. So that would be numbers 1, 2, and 3 on your page 21. The second part of coding messages, which we are going to spend a little more time on, we're going to do the lecture today, get it over with, is using a keyword. So if you think about if every letter of a word or of a shift cipher is the same amount of letters, like a +3, it's very easy to break. Like we were able to get math is fun pretty easily. What's much harder is to use a keyword. So what we're going to do is we're going to use a tool for hiding the frequency clues, meaning frequency clues means if everything's +3, it's very easy to repeat. But what we'll do is we are not going to add the same amount each time, and the matrix makes that extremely easy. Here we go. We are going to look at this phrase, meet me at the mall. And we are not going to shift it by a common cipher, meaning not the same amount each time. What we're also going to do is use a keyword. But in order to make this into a matrix, we can't use letters anymore. See how when we did these, this was letters shifting to other letters. With a matrix, we know we're going to be numbers based. So what you do here to start, this is coding a message with a keyword, is you begin by turning the letter into its exact number. So the message as numbers is meet, M. If you look here, M is 13. So that's why the first one is 13. EET, 5, 5, 20. These are the exact numbers that go with the letters. Now, next, spaces are zeros. So that's why after meet is a 0. And now this is in numbers. So step 1, again, reiterate. Step 1, letters go directly into numbers. Spaces are zeros. Step 2. Step 2 is to think of a short 3 to 5 letter word. 3 to 5 letter word. Any word. And that's going to be the keyword. Now, the keyword will tell you how many letters to shift by. But it won't be the same. So let's take this very slowly. This is it. This is how you code the message right here. This slide right now. The first thing you do is you say how many letters is the key word. It's 4 letters. So what you're going to do is turn your original message, 13, 5, 5, 20, 0, into a matrix, the whole thing. And the number of columns of the matrix, 1, 2, 3, 4, will be however many letters the keyword is. So I'm going to reiterate here. Look. Fish was 4 letters. So you make 1, 2, 3, 4 column matrix of your original message. And you just put them into place. When you get to the end, you go to the next row. Meet was 4, then 0. Me, space, at, space, the. Look, T-H-E. It's okay if it's not together for a word. Now, look, this message ended at a 12, but a matrix can't end. So you just put zeros to finish the matrix. So it's a nice matrix. This one is 5 rows, 4 columns, but it was 4 columns because our keyword was 4. That's why it was 4. Now, the next step of this is to code it. In a regular shift cipher, we would have added the same number to each letter. In a keyword cipher, fish. See, this would be F, this would be I, this would be S, this would be H. So the 13 gets added to 6, the 5 gets added to 9, the 5 gets added to 19, and then the 20 gets added to 8. This is so you can't see repeated patterns. But it's still just adding numbers. So how many times did I write fish? I wrote fish 5 times. Why? because my message took 5 rows to make the whole message. This is your answer right there. That is the coded message. Each of the first numbers would add 6, the second number is 9, then 19, then 8. And then, so you don't give away your secret, you rewrite the message as just a string. Notice how you can't even tell which numbers are spaces. You can't even tell where the words end. It is a thoroughly coded message. The secret here is the person decoding it needs to know that fish was the key word. If they know the key word and the message, then they would set it up the exact same way by taking the answer and then just subtracting, because we added to make the code, you would just subtract this exact matrix. So to decode, again, let me go back to decode. To decode, you take the answer, it becomes the start, and then you just subtract, and then you'll get back the original message, and then you've decoded. What you'll do is on page 21, you are going to do a keyword cipher as well. The second part of page 21 is a keyword cipher. You can feel free to exchange it with someone at home, but what we're up to, and see, this is how you would decode it again. You take the answer, subtract the code word as many times as you need it, you get back the original. And then you put it back into its original M135520. So, what we are up to is the end of coding a message. You are going to, today, you watch the lecture. Next class, you will complete page 21 and you will submit it. The class after that, I'm going to post this YouTube link and you are going to do a virtual video presentation. You're going to watch how code breaking and using ciphers literally won the Allies the war in World War II. So that'll be our third class. After that, we'll come back together and we will work on game theory. Don't worry about these days. We'll work on game theory. We'll do a review and we'll take our second matrix test. But that's a few days away. That's a couple weeks for us here. So in a couple weeks, we'll take another test. But again, today was lecture. Next class, you'll do page 21. And the class after that, you will watch a presentation on breaking Nazi secrets and winning World War II. So please make sure when page 21 is due, you hand it in. Thank you guys very much. See you next time.